Today I will show you how to run calculations using the Material Property Optimizer. I will demonstrate this for stainless steel, but the material type can be changed from the menu. The interface has been designed to be easy to use and as intuitive as possible. It is divided into 4 tabs where you can set different types of parameters, run the calculation, and visualize the results. The first tab is called Composition Range. This is where you set the design space for the optimization. All the available elements are listed in the table on the left. They can be moved by dragging and dropping or clicking the arrow buttons. Elements with a non-zero concentration in the table on the left will be fixed during the optimization. I will add some silicon and carbon here. The table on the top right is where you set the variable elements. I will move chromium, manganese, and nickel here, and input start and end values for the concentration. This is all you need to run a calculation, but there is another table on the bottom right where you can set constraints between variables. For instance, I can fix the total content of manganese and nickel to a certain value. The second tab is called Fixed Parameters. This is where you control the JMatPro extended general calculations that run behind the scenes during optimization. I will use the default settings, but you can change the stepping temperatures and heat treatment temperature, select the phases used in the calculations, and toggle phase boundary search for more accurate boundary values. The third tab is called Target Properties. This is where you set the objective space for the optimization. The properties are listed on the left and they can be moved by dragging and dropping or clicking the arrow buttons. To set an objective, you have to double-click the objective type cell and choose whether you want to minimize, maximize, or target a certain value. For this example, I will minimize the density and maximize the Young's modulus at room temperature. If you want to enforce a constraint during optimization, you can use the table on the bottom right. For instance, I can move phase amount here, double-click and select the sigma phase, and set a constraint to make sure that this falls below a certain limit. Now that we've set the variables and objectives, we are ready to run the calculation. This is done in the final tab called Optimization Results. To run the calculation, simply click the Start button. As the design space is explored, new solutions are added to the chart on the top left, and progress is shown in the log on the bottom. In general, the objectives can be contradictory, so the result is a curve that gives the best trade-off solutions. The algorithm works in a way that tries to fill in empty areas first, so you quickly get an idea of the shape of the Pareto front. If you click a point on the curve, the details for that particular solution will be shown on the right. You can find out the composition and exact property values and constraints. You can navigate through the results using the arrow keys on your keyboard. The calculation will stop once no further improvement can be made or after a time limit or function evaluation budget is reached. These can be changed in the Settings menu. If you're happy with the results, you can also click Stop to finish the calculation at any time. And that's it. As you can see, it's quick and easy to use the Material Property Optimizer.